So today is really just more law of sines and cosines. We're going to do some applications, and Haley even has a really good question for us to start with because she did some homework. But just review for me, if it said to write the law of sines, what would you write down?
Law of sine, sine A over A is equal to sine B over B.
Yeah, you don't have to write all three parts, but you can. All right? And make sure you use capital and lowercase letters to indicate angles and sides. What about law of cosines? If you have to write that tomorrow or Friday. Yes. Good job. Okay. Does anybody know the area formulas? Or can you at least find them? Good job. And do you remember how to find S? Okay. And the other area one?
1/2 AB sine C.
Okay, there we go. Everybody good? All right. The question asked to start us off today is number 9. Is this the one? Okay. I think this is kind of a two-parter, maybe, where you have to do two things. I don't really remember. The shadow of a tree. Okay, so I'm thinking that our tree was here. Oh, okay, we need a little cursor. The usual difficulties with the tablet. Okay, so I'm thinking the tree is here. And the shadow of the tree lengthened as the angle of elevation of the sun changed from 60 to 40 degrees. So I'm thinking that the shadow went out here when you had to look up 60 degrees, and now the shadow is out to here when you only have to look up 40 degrees to see the sun. Find to the nearest foot the height of the tree. Ah, interesting. Where's the 70 go? Yes, the 70 is this difference. I think this is how much the shadow changed. Good job. Okay, now I think we need some geometry. Eventually we want the height of this tree, but I think we don't know any lengths in this little triangle yet. But what's some geometry you know that would help us with this weird little obtuse triangle over here? This is 90. Okay, how did he get that? Okay, 180 minus 60 here. Those are called a linear pair or supplementary, or they make like half a circle even, I tell students, you know, when you have two lines doing this. Now once we know, probably shouldn't have written that in the same color as the other one, but once we have this 120 and this 40, that's 160. So that makes a 20 up here. We could deal with the fact that this is 30 because this makes 180 in this triangle, but I don't think that's going to help. We need a side length for the right triangle. How could we find that? Yes. Let's see. I think we can find this. Okay. So we're going to find this first, and then we'll be able to find the height. All right, so how can we set up law of sines to find that x in using this triangle over here? Let me redraw real fast so it's clear on the video. This is actually, well, it would be clear only if I could draw. Sine of 20 is across from 70. In the same way, the sine of 40 is across from x. Make sure we're in degrees. Anybody get 131.6? Okay. And then if we take out just the little right triangle, we have a 131.6, and this was 60, and we're trying to find this height, which is not a hypotenuse, by the way. So I could just use opposite over hypotenuse, plain old right triangle trig, or you can do law of sines again, it'll work. The sine of 60 equals opposite over hypotenuse. All right, one way I got it rounded to 113.9 and one was 114, so somewhere in there, depending if you use the whole decimal or part of the decimal. That's a great question, though, Haley, because there are several on the homework where you have to do those, find something else to be able to find something else. I don't think the first time through we put one of those on the quiz, though. Okay. What else, guys? Anybody else try any of the homework or have a question? Otherwise, I'm just going to do a few random ones on the packet, probably ones that aren't assigned. I don't know if one was assigned, but it's just a right triangle. Again, the angle of elevation should always be against the horizontal line, so this would be 66. But I will... Okay, 15 meters from the base of the building would be down here. Find the height of the building. Does this meet all the way to the top? Oh, the elevation to the top is, okay. So what function would you use there? Do I need to do law of sines or cosines on that one? No, what can I use?
Just sine 60.
She's not here. Sorry.
Sine 60.
Thank you.
And
Tangent of 66 equals opposite over adjacent. So 15 times the tangent of 66 would give us the height. Anybody get an answer? 3.7. Oh, it does say to the nearest meter, so. Are you assigned number 2? This picture is really hard and tiny, so you want me to skip that one? Are you assigned 3? Yes. Is it circled? Okay. Where, if this is a 57.6, where's another 57.6, guys?
on the top there.
Yes. Alternate interior angles. So there is also a 41.3 here and up here. All right, it says a valley has a cross section shown. A bridge is to be built from A to B, supported by a pier at C. Okay. How high to the nearest tenth of a meter will the pier be? Okay. Anyway, we need this height here, I think. Hint, find either AC or BC first. Okay. This is the same thing we just did on the last one, right? The only distance we have is this whole thing up here. What does that say, guys?
825.
Okay. So we in this giant triangle, which I have not drawn well, 825.6, 57.6, 41.3. Can we then find this guy in that triangle? 180 minus 57.6 and 41.3 leaves 81.1. Did anyone else get that? Okay. Now what? It says we can either find A to C or B to C. Which one do you want to find? The little b or the little a? We need one of them. Which one? Little a. Okay. So if we want to find this side over here, sine of is across from 825.6 in the same way the sine of, it's a 7, right? 57.6 is across from little a, we're calling it. Okay. A lot of typing there. 825.6 times the sine of 57.6 and then divided by the sine of 81.1. I got 705.6. Anybody? Okay. Right, now what are we going to do to find height? In this right triangle, we just found a 705.6. And what else do we know in that little triangle? We know there's a 90 and 41.3. Could we use that 41.3? The height would be opposite, and this would be hypotenuse, so you could use law of sines again, but the sine of 41.3 equals, and I have no room. Oh dear, goodness gracious. No. Equals, opposite over hypotenuse would be h over 705.6. Totally crammed in there. So 705.6 times the sine of 41.3. 705.6 times the sine of 41.3. 465.7 or 466 or something. Feet, meters, does anybody have a label? 1/10 of a meter. Okay, how high to the nearest 1/10 of a meter? Apparently I'm not supposed to round. So 465.7, yes? All right. This figure is missing, so you can skip this one. 5 wasn't assigned, I think, right? Is it assigned? It's a really nice question if you remember some geometry. If this is an isosceles trapezoid and this angle is 132, does anybody remember how this goes? Yes, it's the supplement, so 48 maybe. And if this base is 10 and the top is 15, does anybody remember what we can do? What if we make a little rectangle in here? This is 10, so this would be 10. 5 left over would be 2.5 and 2.5. And then you could use this little triangle on the side here to find the height. Opposite over adjacent, so the tangent of 48 degrees equals opposite is h, I can't write. Opposite over adjacent. Did I do that right, guys? Opposite adjacent, I think so. Tan 48, close parenthesis, times 2.5 makes the height 2.78. If I leave 2, I'm just willy-nilly carrying an extra place here till the end of the problem. Okay, how do you find the area of a trapezoid, though? You could do the triangles and the square rectangle separately, but do you remember the area of a trapezoid? It's the average of the bases. Okay? You probably learned it this way. 1/2 height times B1 plus B2. Does that look familiar? But do you understand that if you take half of if you just average these and multiply by the height, it's the same thing? This helps me remember it a little better. So the bases are 10 and 15. And the height is 2.78. So I got the area to be 34.75. So I don't know if it was 34.7 or 34.8. No units anywhere, right? It would be square units. All right, that was just a good little review of some geometry. 6 is not assigned. 7 assigned or not assigned? Okay, this one does give you some hints and you would have to use 2 steps. 8 assigned or not assigned? Okay. What are you going to want to do here? Yep, you want to find this side and this side by law of sines, right? We got to find that missing angle. This is 17 degrees. And then find the total perimeter. How are you going to add on 5% though? Take your perimeter times 1.05 would be genius. All right, so everybody's okay, they could do that one? All right, we did 9. 10 assigned or not assigned? Okay, this is a kind of tricky one, but we can start out by just finding this missing length. Anybody notice what we can do right away to find this one? Yeah, this is p squared equals what? Plus 2.1 squared minus 2 times 1.5 times 2.1 times the cosine of 27.5. Can we do this one real quick? Ooh, I got p squared is 1.07. Did anybody get that? I probably would have forgot to square root. But if you square root that, p is 1.04. Okay. Now, the idea here is somebody who Al starts out and walks this way, and Bob starts out and walks this way. If they walk at the same rate, how far will they meet away from A? Well, they'll cover the same distance, right? If they're walking at the same speed and the same amount of time. So they're each going to walk half of the perimeter. Can you find the perimeter? (1.04) plus 1.5 plus 2.1 is 2, 3, 4.64. Okay. And then if we cut it in half, they should each walk 2.32. Okay. So the question is, how far past A do they meet up? How could we do that? Means Bob, no, this isn't Bob, this is Al. Al walks here to here, right? So we want this little bitty piece, so Al walked half of this minus the 1.5 it took him to get down that street. What's left? 2.32 minus 1.5 is 0.82. Approximately 0.8 kilometers past A. Right. I don't know that I would ask that, but I could definitely ask you how long is side AB over here. Could you find how long side AB was? Okay. 11 do you have to do? Okay. All this wants to know is how far this is, so that's what kind of question? Yes. Do you have to do 12? Okay. Find the distance between A and B. According to the picture, it looks to me like that's also just what? Law of cosines. Okay. 13 is crossed off because it's a hot mess. 14 do you have to do? Okay, this one is like the one we did yesterday about the blimp. It says, a hot air balloon is seen over Park City, Utah, simultaneously by two observers 2.32 miles apart. Assume the balloon and the observers are on the same vertical plane and that the angles of elevation and distances are as shown in the figure. How high above the ground is the balloon? You need to find either the distance from A to the balloon or B to the balloon first. So we need to find this side or this side, and then we can go back and find the height. You need to treat it as one big triangle first. Anybody have a preference? What if I said on the quiz, find the shorter side? The smaller angle here would be this, right? So let's find that one, just because there's something on the quiz about something like that. Not this question, but 180 minus 28 and 37. So this is a 115 degree angle up here. Now what? Okay, if we find that side then, anybody get that side? Okay, now how's that going to help us find the height of this balloon? If I drop down a height here, can I take that triangle out? You just told me this is 1.2, this is 37, and I want the height, right? Yep, sine or law of sines to find the height. I'm going to let you guys finish. It's a homework question. Mine starts with a decimal and ends with a 7. Did you get that? It also needs a label. Was it miles? Okay. All right. Do you have to do 15? No. 15 is kind of confusing. You do have to do 16? Okay, I'm not going to do 16, but I think there's one like it on the back, 19, maybe 18, that you don't have to do. Should we do 18 real quick? The sides of a parallelogram have lengths of 18 and 26, and one angle's 39. Do you know all the angles then? Yes, good remembering your geometry. 141 and 141. Now, this is the problem. Yes, this is 26 and this is 18. Find the length of the longer diagonal. Which is going to be the longer diagonal, guys? 39 to 39, okay, would be longer. Somebody's going to cut 39 in half. Does that diagonal cut 39 in half? It does not, okay? Okay, it's kind of, you can kind of tell up here by my bad diagonal, okay? It doesn't cut it exactly in half. Only if it happened to be a rhombus would it cut it in half, but this is clearly not a rhombus. But can we find the length of that diagonal quite easily? Because we have two sides and an angle in between here, so we could use what? Law of cosines? Just because you're my favorite class, right? I think the question on the quiz, I maybe ask you to find like one of these angles in here. Well, I should call it something other than X. Call it A. So to find that angle in there, you would actually use law of sines, right? So, okay. Something like that's on the quiz with a parallelogram. What did I skip? 17 was crossed out. Do you have to do 19 or 20? I feel like we've done this a couple times though. I can help you label the picture, but then I think I'm going to leave you on your own. This is 600. 19 and 21, it doesn't really matter. This one looks a little bigger to me. I'll put the 19 and the 21 there. Angles of elevation, find the height of the flagpole. You're going to have to treat it as one big triangle first, okay? And then find one of these. Which one do you want to find first? That guy? So find X using the big triangle. And then you'll be able to use the right triangle to find H, okay? Yep.
On that last one you did, 16, it asked for a shorter diagonal.
I did 18. Okay. 16 has different numbers and different information, yes. But on 16, if the sides are 3 and 8, this would be 35, and this would be the shorter, so it's even easier, really, right? But still law of cosines, but you didn't have to do any extra work. Okay. Anything else? No other homework questions? Okay. I'm going to leave the video under 30 minutes then.